Ever wondered how the rust on your bike forms or how fireworks light up the sky? Chemical reactions are at work all around us. Today, we explore a captivating world where molecules transform through five distinct reaction types. We will journey from synthesis to combustion to reveal the science behind everyday phenomena. Imagine two or more simple substances combining to produce something new and complex. This is a synthesis reaction. In a synthesis reaction, atoms join to form compounds. One classic example is the industrial creation of ammonia through the Haber process. In this process, nitrogen and hydrogen combine to form ammonia. This reaction is fundamental in producing fertilizers that bolster global agriculture. Synthesis reactions form the backbone of many natural and industrial processes. They guide us in understanding how complex molecules arise from simpler units. Now picture a single substance breaking apart into two or more simpler substances. This is the essence of decomposition reactions. In decomposition, a compound breaks down under the influence of heat, light, or catalysts. Consider hydrogen peroxide. It decomposes into water and oxygen gas. The oxygen released is critical in disinfecting wounds and killing harmful bacteria. Decomposition reactions are vital in nature and medicine. They help us understand how substances reduce to their basic components when conditions change. Shift your focus to the idea of one element replacing another in a compound, a process known as a single replacement reaction. Here, a more reactive element displaces a less reactive one. A well-known laboratory example is the reaction between zinc and hydrochloric acid. Zinc takes the place of hydrogen, producing zinc chloride and releasing hydrogen gas. This reaction not only demonstrates elemental reactivity, but also deepens our grasp of how substances interact. It challenges us to see hidden exchanges in everyday chemical interactions. Next is the double replacement reaction. In these reactions, ions in two compounds exchange partners to create two new compounds. A vivid example occurs when mixing sodium chloride with silver nitrate. This swap results in the formation of sodium nitrate and a white precipitate called silver chloride. Visualize the moment when clear solutions suddenly change as solids form, marking nature's subtle interplay between compounds. Double replacement reactions find use in various industries, including water treatment and manufacturing, providing simple yet powerful illustrations of ionic exchange. Finally, we observe combustion reactions. These reactions occur when substances react rapidly with oxygen, releasing heat and light. A familiar instance is the burning of propane. When propane combusts in oxygen, it forms carbon dioxide and water, while releasing energy that heats our homes and cooks our food. Combustion reactions power engines, stoves, and even fireworks. They demonstrate energy transformation in raw, visible form, reminding us that chemical reactions are often the source of both light and life. Each reaction type offers a unique perspective on the dynamic world of chemistry. We begin with synthesis reactions that build complexity from simple beginnings. We then learn from decomposition reactions where a compound splits into clearer, simpler parts. The single and double replacement reactions show how elements and ions exchange roles, and combustion reactions remind us of the power and beauty of energy release in our daily lives. Taken together, these reactions form a complete picture of chemical change. Understanding these processes may seem challenging at first. The world of molecules can be mysterious, filled with rapid changes and hidden exchanges. Yet, with clear examples and real-life applications, the puzzle becomes less daunting. Each reaction type is a window that opens our eyes to the intricate dance of atoms and molecules that sustain our world. Chemistry, far from being abstract, is a practical and essential element of everyday life. This journey through chemical reactions reassures us that complexity can be understood systematically. The seemingly complicated behavior of atoms is broken down into clear, understandable segments. This understanding illuminates topics in industry, environmental science, and medicine. Chemistry is not just a subject to study, but a powerful tool that explains natural phenomena and drives innovation. Explore the fascinating world of chemical reactions and see how they shape our daily lives.